So you want to learn about parallel lines, huh? Well, you've come to the wrong place because learning it anywhere else would be better, but okay, whatever. And if in any point of the video I say something objectively wrong, pretend that it isn't. Now, normally when teaching math, people use paper, but because we've run out of budget, we're using bars. Don't ask how we were able to afford bars, but whatever. Now, you want to know what a parallel line is? Well, it is when two bars are right by next to each other and they're at the same angle. Now, that's the basics down, but now we're going to be talking about stuff that happens when you introduce a traversal into the mix. A traversal is the line that is going through both parallel lines and is a line that is not parallel to any other line because it's physically impossible if you know the definition of parallel, which I'm hoping you do because I just explained it to you. Because we've added a traversal, we've now introduced 8 separate different angles to this current problem. Now, to keep track of them, I'm going to number all of them from 1 through 8, like so. Now that we've labeled our angles, let's now start identifying which of these. We'll start with corresponding angles. A corresponding angle is an angle that shares a relative same position to another angle. An example of this would be 2 and 6, 5 and 1, 7 and 3, 4 and 8. That is because they are basically in the same position, just on the other end of the pole. Now let's go on to alternate interior angles. Alternate interior angles are basically angles that are inside but are on the opposite side. For example, 3 and 6, 4 and 5. Now, alternate exterior angles are the exact same thing, except they are for the outside. For example, 1 and 8, 7 and 2. Now we're going to be finding the vertical angles. And basically what vertical angles are angles that are directly above one another. For example, 5 and 8, 7 and 6. These angles are vertical angles, and they are basically that because 5 is directly above 8, and 7 is directly above 6. Now, one thing important to know is that let's just say a traversal line goes through a line, and the angles, two angles created, are originally on one side. Well, these new angles created will actually be supplementary, meaning that they will both add up to 180, and this will help us later into finding the actual measures of these angles. Now picture this. You paid an underpaid employee to write down the measurements of all the different angles, but he just straight up goofed around and only did one. What can we do? How can we find all of the other ones? Well, supplementary angles will actually help us find the measurement of all the different angles. Now let's just say the only angle that was labeled was number 2, which is 63. How is it possible to find literally every single one? Well, remember that rule I told you about supplementary, about how if they're on the same side they will add up to 180? Well, this will come in here. And because 2 and 1 add up to 180, all we gotta do is subtract 2, which is 63, from 180, and we'll find out that number 1's angle is actually 117. And because we've already identified that in the corresponding angles that 5 and 1 is the same and 2 and 6, it now means that 6 is equals 63 and 5 equals 117. That's already half of them done. And because of the vertical angles rule, all of the measurements of the angles will go down to their lower angle. For example, 1 will go to 4, 2 will go to 3, 5 will go to 8, and 6 will go to 7. And all of these changes are now on the screen in front of you. And that's it. Congratulations, you learned about parallel lines and the relationships created when it is intercepted by a traversal. I hope you enjoyed this video that I created, and I hope I get something that isn't an F, maybe a D.